Okay, in this video we're going to talk about graphing linear functions by finding X-intercepts and Y-intercepts. So there's other ways to graph linear functions. You can use slope-intercept form, is definitely another way that's very common, but this technique actually works to find X and Y-intercepts in general as well. So the idea with a linear function, one thing that kind of makes them special is if you have 2 points that you know that the function goes through, since it's linear, well, it's got to look like a line. So how about we move that point up a little bit? We know it has to be, since it's a line, 2 points uniquely determine the graph of a linear function. So in order to graph the functions, what we're going to do is, instead of kind of finding 2 points arbitrarily, we're going to find 2 specific points. Namely, we're going to find the Y-intercept and we're going to find the X-intercept. And once we have those 2 points, we can just simply connect the dots and that'll give us the graph. Well, how do we go about finding, for example, the Y-intercept? Well, the thing to notice is, to find the Y-intercept, anywhere along the y-axis, what does the x-coordinate have to equal? Well, no matter what height you're at, the x-coordinate is always 0, and the y-coordinate is the value that we don't know and we're trying to figure out. So basically it says, to find the y-coordinate, we should let x equal 0. To find the x-coordinate, think about it the same way. Anywhere along the x-axis, we don't know what the x-coordinate is for this point generically. We would like to find it, but we know that the y-coordinate has to be 0. So we'll simply plug in y equals 0 and solve. So again, in summary, it says to find the x-intercepts. Okay, so the x-intercepts, it says we'll substitute y equals 0 and solve for x. It says to find the y-intercept, we're going to substitute in x equals 0 and then solve for y. Okay, so let's do a couple examples here. Obviously one thing that's going to be important is simply recognizing in the first place that what you're given is a linear function. Maybe the instructions will just tell you, hey, this is a linear function and graph it. So suppose the instructions say graph, we'll say 2x plus 4y equals 12. And we'll do it by the method of finding x-intercepts and y-intercepts. Again, when I look at this, I see an x to the first power, a y to the first power, neither of which are in the denominators of any fractions. And then an equal sign and just kind of numbers floating around. Notice, again, the exponents on the x and the y are to the first power, so that is going to indicate that you have a linear function. So again, to find the y-intercept, I'm simply going to plug in the value of 0 for x. So if I plug in 0 for x, I'll get 2 times 0 plus 4 times y equals 12. Well, 2 times 0 is simply 0, so I'm left with the equation 4y equals 12. If we divide both sides by 4, not by y, by 4, we'll get the value of y equals 30. So it says when the x-coordinate is 0, if you imagine making plotting points, it says if you plug 0 in, you get 3 out. So 0, 3 up here is going to be a point on our graph that our linear function goes through. And now the other thing that we'll do is we'll find the x-intercept. And to find the x-intercept, we'll simply substitute in, again, a y value of 0 this time. So if I plug that into my equation, I'll get 2x plus 4 times 0 equals 12. So again, 4 times 0 is simply 0. This is the point of plugging in x equals 0 or y equals 0. It reduces to an equation with just one variable. We'll get 2x equals 12. Or x equals 6. So again, if you think about your little chart over here, It says if you plug in the y value of 0, we get 6 out for x. So we'll be over here at the point 6, 0. We'll play connect the dots here. See if I can't get it there. That looks pretty good. And there would be the graph of our function up here. Whoops. Here's our graph of the line 2x plus 4y equals 12. Okay, so maybe we can do one more here real quick, I think. Maybe I'll go through this one just a touch faster. Alright, let's fix our graph up here real quick. Okay, so, I don't know, let's graph 3x minus 2y equals 8. Okay, again, so the exact same idea. If we want to find the x-intercept, obviously the order you do this doesn't really matter. If you find the x-intercept, to find the x-intercept, we'll let y equal 0. So we'll get 3x minus 2 times 0 equals 8. Again, 2 times 0 is 0, so we're left with just the 3x equals part of our equation. If we divide both sides by 3, we'll simply be left with x equals, well, 8 thirds. 8 thirds, again, is what, 2 2/3? So I usually just leave my numbers as fractions. I don't make them as mixed numbers. And likewise, to find the y-intercept, we'll do a very analogous thing. We'll simply substitute in x equals 0. So we'll get 3 times 0 minus 2y equals 8. 3 times 0 is simply going to give us 0, so that part's gone. Divide both sides by -2, and we'll get a y value of -4. So this time our graph is going to have a y coordinate of -4. Again, 2 points is enough to determine the graph of a linear function. We just play connect the dots here. And again, there's the graph of your linear function now. 3x minus 2y equals 8. So hopefully nothing too bad. I think, the worst thing that might happen again is your equation, you just end up with kind of weird numbers or weird fractions, whatever those are. But otherwise, I think doing the x and y-intercept method is a pretty good way to graph linear functions. Again, if a linear equation is y equals, it's just going to be a horizontal line. So maybe that's y equals 2. X equals 8 thirds would be a vertical line. Okay, so you still need to recognize that those are linear equations, but any other type of linear equation, you can do this trick of finding x-intercepts and y-intercepts. So I hope this helps you out. If you have any questions, shoot me an email. I'll be happy to try to make some sense out of it.